Lesson 5.7, Using Congruent Triangles, Part 2. Essential question, how can you use congruent triangles to make an indirect measurement? All right, let's take a look at this situation and see how we use indirect methods. And let's take a look at what a surveyor might want to do. A surveyor wants to figure out how wide the river is and doesn't want to take a measuring tape from one end of the river to the other river. And so we'll place some stakes here. We'll place a stake at N. We'll place a stake right here and then make another distance that's exactly the same right here. And then we'll make a right angle and go off until they can make a straight line right here. Make a straight line so that all of these are collinear. So a surveyor will do that. And we're going to be able to see that these triangles right here are congruent by ASA, and I'll help you see that. See, these are vertical angles right here. So we can get triangle LKM congruent to triangle. Now here's the right angle, K, so it has to go with N. And then right here, the M's have to go together. And then this is the P. And we can get these triangles congruent by angle, side angle. Now once the triangles are congruent, then we know that LK will be congruent to NP. Now remember, NP is what we're trying to find, the width of the river. So NP will be equal to LK. And so the surveyor, all the surveyor needs to do is walk and figure out what this distance is that they've walked so that they could align these collinear points. And now they know the width of the river. All right, let's take a look at some more proofs. The pictures are getting a little bit more complicated, and let's see what we can do here. All right, I'm looking and I can see some given. I can see that I'm going to call this angle 3 and angle 4 so that I don't have to use 3 letters. I'm going to write down everything that I see. Number 1, I see angle 3 congruent to angle 4. I see angle A congruent to angle D, and I see AB congruent to CD, and that's all in the given. 2 pairs of angles means I'm not going to use this one or this one. There's no right triangles. And all I've got to do is examine whether the side is included or not included, and I can see it's angle, angle, side. So I can see that this is going to be my plan. Step 2, I'm going to write out the triangle congruence. AEB congruent to triangle. Remember, A goes with D, so here's the D. Angle E goes with angle E here. And then there's only one letter left, which is C. So with not too much work, I got these triangles congruent by angle, angle, side. Now, how's that going to help me get angle 1 and angle 2? I want you to notice that angle 1 and angle 2 are from the same triangle. So I know that I have these theorems. If 2 sides of a triangle are congruent, then the base angles are congruent. This is the base angles theorem. So if I could somehow show that this side is congruent to this side, then these 2 angles are congruent. And that's going to happen because I've shown these triangles are congruent, so I'm going to use a different color. I know these will be congruent, and those will be congruent by corresponding parts. So congruent triangles are congruent. So I can say BE is congruent to CE, and I'm going to say corresponding parts of congruent triangles are congruent. Now that I have that, I can say step 4, I can say angle 1's congruent to angle 2, and I can say in a triangle, if 2 sides are congruent, then the angles opposite are congruent. That's our base angles theorem. So again, another proof using congruent triangles that gets us to a very interesting situation. All right, next one, the picture's getting a little bit more complicated, where I've kind of started half the proof. We have angle 1 congruent to angle 2 and angle 3 congruent to angle 4, and we'd like to prove that these little triangles are congruent. Right now, though, I drew the figure again without this. And the reason I'm doing that is because this is angle 2. This is angle 2, and this is angle 1. This is angle 4, and this is angle 3. If I eliminated this side, it's very easy for me to prove these two triangles are congruent with a reflexive. So I'm going to go ahead and prove these triangles are congruent. They're not the triangles I want, but they might give me some information here. So I've proved those triangles are congruent. Now, what kind of parts can I get out of here? So now that these triangles are congruent, I can say, and I'm going to put this, I can say that this side is congruent to this side. And that might be helpful when I'm trying to prove these triangles are congruent right here. So I'm going to write CD congruent to CB, and then I'm going to write corresponding parts of congruent triangles are congruent. Okay, now I'm going to mark it here in the original diagram. And I'm just going to concentrate on the triangles now here that I have here. All right, so I am now worried about another pair of triangles, and I'll continue this in green. So step 5, I've got CD congruent to CD. I've also got angle 2 congruent to angle 1. And that's from the given. I'm just using the given again, but in a different triangle. And then I have this reflexive side right here. CE is congruent to CE, and that's reflexive. And now I've got side angle side. So now I can get these triangles, which is the ones I wanted, congruent to triangle DCE, and the green triangles are congruent by side angle side. All right, so let's talk about this. This is the most difficult proof we've had so far. What we did is, with these three, we proved one pair of triangles that gave us some parts that was going to help us with the triangles that we wanted. Some people call this a detour proof. You're taking a detour. You're trying to prove a pair of triangles, going on a detour to get information, and this is the information we wanted from those big triangles that helped us get to the little triangle congruence. All right, let's take a look at the construction for copying an angle, and now we're ready to figure out why the construction works. All right, so remember that when you're trying to copy an angle, you draw a side, you make an arc, you make sure that it opens up the same amount, and then you draw the side. Okay, so when you draw these arcs, you're forcing all of these sides to be the same. The compass is in the same length. So all of these right here are congruent because the compass is at the same length. Now, right here, when you measure from here to here with your compass, you're measuring right here, we're ensuring that this and this are the same right here. So the compass settings are forcing all these distances to be equal. Well, all of them represent sides for SSS congruence theorem. So really what we're doing in this construction is we're creating two triangles that are congruent by SSS. Now when that happens, then this angle right here is congruent to this angle here by corresponding parts of congruent triangles are congruent. And that's why the construction works.